So now that we've given the motivation for the prototype pattern in the context of our expression processing tree case study, let's go ahead and take a look at the structure and functionality to learn more about how the gang of four describe this pattern. So the intent of this pattern is to specify the kinds of objects to create using a prototypical instance and then create new objects by copying this prototype. So that's basically the nuts and bolts of the prototype pattern. You find a way for an object to clone itself. When should you apply this pattern? You should apply this pattern when the classes to instantiate are specified at runtime. As you can see here, depending on how we've configured the iterator, the decision about what kind of concrete strategy we have here is a runtime decision, which of course is made in conjunction by using factory methods like begin and end on our expression tree. So all this stuff is done at runtime. There's also a need to avoid the creation of a factory hierarchy. We don't have a hierarchy of factories as we would with the factory method pattern or the abstract factory pattern. Instead, what we do is we have our hierarchy of strategies, which are represented by our different iterator impulse subclasses. And then we go ahead and just define the clone method for each of those. So there really isn't a factory hierarchy. There's a hierarchy of domain objects that happen to all have a method called clone to make a prototype of themselves. And you should also consider applying this pattern when it's convenient to copy an existing object rather than creating a new one. So you can see here, when you say clone, what we're going to do, or when clone is called by the abstraction portion of the bridge pattern, what the clone implementation does at each derived class in this hierarchy is it uses the copy constructor of itself to make a copy of this object. So it does essentially a copy of the state of that particular object at that particular point. Here's a diagram that demonstrates the structure and participants for the prototype pattern. As usual, it always has that common look and feel, right? You've got some client on the left-hand side where operations are invoked. There's a bridge-like entity to go over to the implementer hierarchy. And here, as always, we have some abstract class, in this case, an abstract base class, and then various concrete classes that derive from that class and fill things in. So this looks suspiciously like strategy. It looks suspiciously like bridge. It looks suspiciously like a couple other patterns we've talked about, but like state, for example, but it is its own pattern with its own intent and own applicability and own capabilities and pros and cons and so on. So the client in this particular case is going to be what the client code will invoke. It's something like the abstraction in the bridge pattern. In fact, in our example, it is playing the abstraction role in the bridge pattern, and this will be the expression tree iterator. And then there's going to be the prototype, and the prototype is the abstract class, which defines the root of a hierarchy of concrete classes. In this case, it's iterator impl with the clone method. And then down here, you can see we have several different concrete prototypes, such as pre-order iterator impl, in-order iterator impl, post-order iterator impl, and so on and so forth. So this should be kind of old hat by now. If you've been watching the other videos, it should make very good sense how we organize things using these patterns.